Hi guys, and welcome to our video lesson on applications involving right triangles. So sometimes we have situations that we want to find measurements in real life, but we really can't do them physically. So what we can do is we can use indirect measurement and trig to find these measurements. So for each of these situations that is given to us, we're going to set up a trig equation to solve. And if we have a picture, we'll use it, but if not, we will draw one. Okay, letter A. You are hiking near a canyon. While standing at A, you measure an angle of 90 degrees between B and C. You then walk to B and measure an angle of 76 degrees between A and C. The distance between A and B is about 2 miles. How wide is the canyon between A and C? So this problem luckily has a picture. So we can look here, and all the information that I just read in the problem is drawn on this canyon. So we have drawn a right triangle. The right angle is at A, and then we have an angle of 76 degrees. We're trying to find the distance across the canyon, which obviously would be impossible to walk across. So let's set up a trig equation, knowing that our 76 degree angle is where we're going from, so that our x is opposite of that, and our 2 miles is adjacent. So the trig ratio that uses opposite and adjacent is tangent. So we will say the tangent of 76 degrees equals x over 2 miles. Now to solve for x, we just have to multiply by 2. So I'm going to type in my calculator 2 tangent 76 degrees. And once I type that in and round to the nearest tenth, I get actually that the canyon is approximately 8.0 miles across. Okay. Some other situations that we can use to measure with right triangles involve an angle of depression or elevation. Now, the difference is from any point you're standing, if you are making an angle and looking upward, that's going to be an angle of elevation. Okay, so like this one. Or let's say if you were standing on top of the building here in this picture and looking downward, that would be an angle of depression. Both of these angles are from the horizontal, so anytime you're at a height, you can think, okay, the horizontal at the point I'm at, just draw a horizontal line. Okay, so let's try B. A surveyor is standing 115 feet from the base of the Washington Monument. The surveyor measures the angle of elevation to the top of the monument as 78.3 degrees. How tall is the Washington Monument? Okay, so what we're trying to find out is how tall the Washington Monument is. So height is going to be a vertical line. So I'm going to draw one side of the triangle, and this is going to be the height of the Washington Monument that I don't know, so I'm just going to put H. It does tell me that the surveyor is standing 115 feet from the base of the monument. So here's the base. I'm going to say, oh, this is 115 feet. And then it tells me that the angle of elevation to the top of the monument is 78.3 degrees from where he's standing. So I'm going to draw the hypotenuse of the triangle and make this 78.3 degrees. All right, now we have a right triangle with enough information to solve for h. From 78.3, our h is opposite of us, and 115 is adjacent. So this is another tangent situation. So we're going to write tangent of 78.3 degrees equals h over 115 feet. And to solve for this one, we'll just multiply by 115. So in our calculator, we will type 115 times the tangent of 78.3 degrees. And when I round that to the nearest tenth, I get approximately 555.3 feet. And that's how tall the Washington Monument is. Okay, the last one we're going to do in this video is letter C. A parasailer is attached to a boat with a rope 72 feet long. The angle of elevation from the boat to the parasailer is 28 degrees. Estimate the parasailer's height, this should say, above the boat. Okay, so we have a boat and we have a parasailer attached to it. So I'm just going to draw a boat. It's just a beautiful boat here. Okay, so let's say the parasailer is hooked on the back of the boat with a rope. And obviously a parasailer is in the air, so this is going to go up. Okay, This rope, it told us, is 72 feet long. This is where my parasailer is. The angle of elevation from the boat to the parasailer is 28 degrees. So remember, angle of elevation is from the horizontal, from where we are starting. So I'm starting at that point that my rope is connected, and I'm going to draw a horizontal. Okay, well, that's not quite horizontal, but you get it. There we go. That looks a little better. Okay, so now that I have that, and what I want to find is the height of the parasailer above the boat. So that I'm just going to drop down from the parasailer to the horizontal. This is going to be the height. So what I have made is a right triangle, and here's my 28-degree angle. All right, let's set up an equation. From that 28-degree angle, H is opposite, but my hypotenuse there is what's given to us. So now we are not using tangent, we're going to use sine. So sine of 28 degrees equals H over 72 feet. So to solve for H, we're going to multiply by 72. So in our calculator, we're going to type 72 times the sine of 28 degrees. And we get that the parasailer is approximately 33.8 feet above the boat. All right, guys, we are going to do the last problem together in class.